today's topic is prefix sum. So basically we have covered this 2 pointers and sliding window, right? So this is something similar to that. Okay, we will be using sliding window here, okay, and calculate the prefix sum of that window. Okay, so what is prefix sum pattern? Basically it is a technique where you create a new array or use a data structure to store the sum of the elements from the startup to each index. Let's say we are having the array 1 2 3 4 5 6, right? So in the prefix sum we will be calculating the sum of each element till a point. Let's say we are traversing this array and first 1 will come, then prefix sum 1 plus 2 3 will come, then 3 plus 3 6 will come, then 10, then 15, then 21. So this is the prefix sum array of this array, right? So we are calculating the sum of each element till the point, any point. Okay, let's say I is here, so this is the prefix sum till this point, means the sum of all elements before this point. So this is what prefix sum, and we usually form it is usually used for array of size n and its prefix sum. We can calculate the prefix sum like this, right? Like I mentioned, the sum of all the elements before the point, let's say I. Okay, so this is the formula: array 0, array 1, array dash 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 till array I, right? So why use prefix sum? Basically it helps to compute the sum of elements in any continuous or contiguous subarray in O1 time complexity. Let's say if we want to calculate the sum till this point, till let's say this point, then what we will do? We will traverse whole array and add the sum of each element in the sum variable, let's say sum, right? So it will take O of n time complexity or the I, right? O of I time complexity. But with the prefix sum we can calculate in O of 1 time complexity, as while we are traversing we are maintaining a prefix sum, right? So rather than O n time complexity, we can calculate the sum of all the elements in O1 time complexity, right? After that there are some steps, scenarios are given. So without prefix sum of elements from index I to j is computed by looping from I to j, right? As I said, we need to traverse the array and calculate the sum and add the sum of each element in some variable and calculate it, right? But with prefix sum we can simply use this, like we maintain this array, right? Prefix sum, and if we want to calculate for this I, we can simply write this thing and we can get the prefix sum or sum of all the elements before this variable or index, right? So sum of I and j will be, see, if we want to calculate the sum, let's say from this index to this is I equal to 1, this is I equal to 3, right? So formula will be prefix of what? J minus prefix of I minus 1. Okay, this we will be using in the questions, so it's important. Let's understand this. So what is prefix of 10? Prefix of 10, prefix of j, that is 3, this is j, it's 10, right? Minus prefix of I minus 1, that is, this is I, prefix of I minus 1 is prefix of 0, that is what? 1. So the sum from of this window, let's say from I equal to 1 to j equal to 3 is 9, right? It's 9, not 9. It's 9. Okay, it's 9. Yeah. Okay, so this is how we will get the sum of some window, right? Clear? So let's move further. I hope you understood this formula. We will be using this in our question. Okay, so to finding the sum for some window, we will be subtracting the sum, right? Let's say, okay, let's say we have the array like 1 3 6 10 15 and 21, right? If we want to calculate the sum from this to this, what we will do, we will subtract the sum till this point, that is this one, minus total. We will get what? We will get this window, right? From whole thing we will subtract this part and we will get this part. So that's what we are doing. That's what this formula is about. Okay, so how to compute prefix sum? So it is a simple step, right? So what we are doing, we are having one array, the prefix array, right? After that the first variable will be same only, right? It will be array 0. So we initialize this, right? First element. After that we are traversing the given array, we are traversing and we are adding the last sum. Let's say we are given 1 2 3 4 5, right? So prefix of 1 will be prefix of I minus 1, that is 0, 1 minus 0, plus array of current element, that is 1, right? Same with different element. Let's say we are here now, so prefix of 2 will be prefix of 2 minus 1, that's it, that is prefix sum till this point, that is sum of all elements till this point, and we will be adding what? The current element, that is 3, right? We will get the sum till this point. So this is what we are using for loop. Now what's next? Where we can apply prefix sum. So it can be useful in many types of questions, such as range sum query. You will be having the question thus, okay, you need to solve this, quickly compute sum of elements in subarray multiple times, right? Number of elements in range, satisfying a condition, finding subarrays with a certain sum. Okay, so 2D prefix sums and difference array. So like this we will be using prefix sum here, right? How to identify problems where prefix sum applies. Okay, so we will look for the questions where they will ask sum of elements in the range or subarray, right? Let's say we are having 1 2 3 4 5 6. We need to find a subarray with sum, let's say anything, let's greater than 10. Okay, so we will be using prefix sum here, and we will find if any subarray or the sum of subarray is greater than 10, then we can say yes, it's possible. So we will return true or the indices of the subarray. Okay, we will solve the question. Need fast repeated sum queries for an initial array is given, after an initial array is given. Okay, so as I mentioned, if we want to calculate the sum of numbers, we need to traverse the array, right? So it was taking O(n) time complexity, but using prefix sum it will take O(1) time complexity, right? So need to find number of subarrays satisfying certain condition. Okay, deal with prefix based conditions. So what are the benefits? Reduces repeated work in sum calculation, as we are already calculating the sum, right? We are maintaining it. Transforming O(n) square time complexity into O(n), right, plus O(1) for the query. After that, simplifies problem logic by leveraging pre-computed cumulative data. Okay, as we are maintaining the prefix sum array, right? Till this everything is clear. Shall we move to questions now? Okay, then easy question. Find pivot index. Okay, so given an array of integers num, calculate the pivot index of this array. Okay, it is the index where the sum of the numbers strictly to the left of the index is equal to the sum of all the elements to the right. Okay, so let's see the example. Okay, so we are given this array, right, and the pivot indexes, like the sum of the all the numbers to the left is equal to the right sum. Okay, so 1 7 3 6 5 and 6. this is the array given, and the left sum should be equal to the right sum, and at that point it will be our pivot index. Okay, so in this case it's I think 0 1 2 3, this one. Okay, let's see what is the sum. It's 11, right? What is the sum? It's 11. So this is the index. Okay, so how can we do this? See what we are doing here. We are maintaining the left sum as well as right sum, right? Till this point, what is the left sum? What is the right sum? Or let's say till this point, what is the left sum and what is the right sum? Anyone? Why can't see? 2 pointers is what we are using. Under 2 pointer we are using prefix sum here. In sliding window also there is 2 pointers concept. Here also we are using 2 pointers only, but within the that we are using prefix sum. But how? Brute force. So no one wants to try, huh? Start a left and the right pointer. After that, Avinesh, store prefix sum and suffix sum. So we will be calculating the sum from both sides, taking 2 pointers. Whatever both are equal, that is the Sujit Reddy prefix sum. How? Just send me the code or something, like or tell me the for loop. Okay, so what we can do, see, first we will traverse the whole array. We will get the total sum, right? Total sum we will get what? In this case 1 7 10 and 11 21 27 28, right? 28 is the sum, 10, then 10 20 28. Yes, so total sum is 28, right? After that, again we will start from the front. Okay, we will start from the front. We will maintain the left sum, and with this also we will maintain the right sum. How we will get the right sum? We can simply subtract this from the total, right? We will get the right sum. Okay, we will start from here. Left sum we will get 1, and the right sum, for the right sum we will also subtract the what? With left sum we need to start with this point. Okay, because we should not include this thing, correct? Here if you see this example, we are not taking the 6, right? Here it's what? Here it's 11, right? Yes, here it's 11. We are not taking 6, so we need to keep this in our mind. So we will be starting from 7. Okay, 7, and the left sum in this is 1. Okay, correct? And the right sum will be total minus right minus what? The current index, that is, this is I. Okay, this is I minus, let's say, nums of I. Okay, we will get what? I think 20, right? 1 and 7 8, 20 is there. Let's calculate. 11 and yes, 20. Okay, in the next iteration it will go to here. I will go to 3. Now the left sum is plus 7, that is 8. Here we are subtracting minus 3, right? So we will get what? 11 plus 6, that is 17, right? And when we move to this, we will get sum as 11. Here also 11, right? means this part, right? This part and this part. At this point, left sum is equal to the right sum. So this is the index, that is I. So we will return this. Simple, not right, it's left. See, in the brute force, what we can do? If you see the brute force 1 7 3 6 5 6, see, you need to calculate the left sum and the right sum, right? What is the brute force? What is the basic approach you are getting in the mind? The basic approach can be like, we will calculate for each index, we will calculate the right sum and we will calculate the left sum. Okay, so we will be having one loop. Let's say this is for left, okay, or right. Let's say for right. So it will start from int I equal to 0, I less than n, or whatever index is this, or I plus plus. Then we are calculating the sum of all the elements after that, right? So we will be having int j equal to I and j less than n, j plus plus, right? So you will get the sum of all the elements. Let's say I is here, you will get all the sum of all the elements after this point, right? So we are using what? N square time complexity here. This is for right sum only, right? Okay, let's move to the code then. So in the code, first we will be maintaining the total sum. Okay, so we can use for loop, for each loop, for nums, total plus equal to num. After that, what? We will be having one left sum equal to 0, and one for loop till when? Till nums dot length and I plus plus. Okay, so in this, now the right sum we will be calculating. Okay, right sum will be total minus left sum minus the current element, that is nums of I, correct? After that we need to check if right sum is equal to left sum. That means this is the index. Okay, this is the pivot index. So we will return this, return I. Otherwise we will update the left sum plus equal to nums of I, right? At the last we will return -1, that no index is there, no such index is there. Okay, let's run this. Accepted. Let's submit this. So it's accepted. Okay, so what is the time complexity here? See here what we are doing, we are traversing whole array, right? So at least on will be there, o n will be there. Now what about this? Okay, you got this on plus on, right? Correct. We can ignore the constant, right? Shall we move further to the next question? Okay, subarray sum equals k. Given an array of integers nums and an integer k, return the total number of subarrays whose sum equal to k. Subarray is a contiguous non-empty sequence of elements within an array. Let's see the example. Okay, so this is the example. We need to return the number of subarrays with sum equal to k, right? This was the question. Sum equals k. Return the total number of subarrays whose sum equal to k. Here the subarray is 1 1 and 1. Okay, this is one subarray, this is one subarray, right? How can you do this? Okay, so let's see the other example also. In this we are given 1 2 3 and 1 2 3 and k is 3, right? So one subarray is this one is this one. So how can we do this? Can we use prefix sum here? Yes or no? 1 1 and 1, right? This was the array. Can we use prefix sum? Yes, we can. How? See, we will start from here, right? We will move further. We will get 2 here, right? 2. Let's make us prefix array, prefix sum sub array. Okay. 1, it is 2, it's 3, right? This is the prefix sum, right? Now we need what? We need sub array with some k, that is 2. How can we find from this? See, first we got this 2, right? So first is this one only, right? This one till this point, the sum is 2. Now for this, how can we check? For this point, this sub array, how can we check from this prefix sum array? We can use the hash map. See, we will use hash map. We will be storing the values of prefix sum. Okay, we stored 1, after that 2, after that 3, and we will be storing the index, but here we need to count the sub arrays, not the index, right? So we will be storing the number of sub arrays. Okay, let me first tell you about the indexes, then we will move to the number of sub arrays. Okay, so we will store hash map. We are having key and value, right? So in the key we will be storing this prefix sum. Okay, 1 2 and 3, and with that we will be storing the values, that is, it's starting from 0, right? It's starting from 1, sorry, it's ending till 1. Okay, for 2 it's 1 1 and 1 till this point, right? So it's ending index is 1. For this it's 2, right? So we will be using this hash map to calculate or to find out this sub array. How? See, we will check 3 minus k if it's present or not in this hash map as a key, right? Its value is 3 minus 2, it's 1, right? 1 is present, that means yes, there is a sub array of size k, right? How? Let me show you. See, till this point it's 2, right? And what is the sum of this array, this sub array? It's 2. So 3 minus 1 equal to 2, right? So we are basically checking if 1 is present, then we can subtract it. That means the sum of sub array 2 is present here. Let's write the code. After that I will explain you with the help of code. Okay, so let's move to the code. We will be having one hash map. Within hash map, key will be of integer type and value will be of integer type. Now here we are not maintaining the indices, right? We need to maintain the number of subarrays, right? So here we will be having value as the number of subarrays with some this thing key. Okay, I will explain you. Map equal to new hash map. After that the initial part will be for 0, map dot put 0. For 0 sum there is only one subarray, right? That means nothing. After that we will be having one variable, that is count, the sum, for calculating the sum, and the count for calculating the count of subarrays with some k. Initially it will be 0 only. After that let's start the for loop from 0 till nums dot length and then I plus plus. After that what we are doing, we will be checking if the value, first we need to add the value in the sum, nums of I. Okay, now we will check if this value is present in the hash map or not, right? That's what we were doing here for checking, right? We are checking if this thing 1 or this value is present or not. That's what we will check. So if map dot contains what? Contains key. Okay, contains key what? Sum minus k, right? We need to check if the formation of subarray with some k is valid or is possible or not, right? So we can check this sum subarray is present or not, basically the subarray with some this value. Okay, after that if it's present, then we will do what? We will increment our count plus equal to sum, sorry, map dot get sum minus k, right? Basically what we are getting here, we are getting the number of subarrays with count with sum this value 1. Okay, after that what? We will put the value the sum, put in what, the sum, and what is the value? We will basically check if it's already present, then we will increment the count, otherwise we will set 0. Map dot get our default sum 0 value, otherwise plus 1. Okay, the default value is 0, right? At the end we will return count. Let's run this. Accepted. Okay, I know many of you are having confusion. Let's try run this. Okay, so what was the array given? Array was 1 1 and 1, right? This was the array given. See, we are starting with the initial condition, right? Map is there, within map key and value. Within value we are storing the number of subarrays, right? With sum the key as key. Okay, so now initial will be 0 and the number of subarray is 1, that is nothing. Okay, then we are starting this for loop, right? We are starting from 0, we are calculating the sum. Now sum will be 1, right? We are at this index, sum will be 1. Now we are checking if sum minus k, right? We are checking this condition for what? For checking if subarray with some k is possible or not, right? So sum was 1 only, 1 minus what? 1 minus 1 minus 1, right? Sorry, k was 2, correct? K was 2, no? Yes, 2. It's minus 1, it's not present, right? It's not present, so it will move to this point, right? Then it will put sum as 1 and the value 1 was there or not earlier, it's not there, so it will be 1 only, right? Correct. Then it will move to this point. Now the sum will be 2, right? 2. Now it will check sum minus k, the value of sum is 2 minus 2 is 0. It's present or not? It's present. Here it's present, right? So it will increment the count. So count will be 1 now, right? That means it is taking the array from the starting, right? We have this initial condition, that is for 0 we are having 1 subarray, right? So basically this is for the starting index, right? So we got count as 1 now, and we will put 2 and the sum, sorry, the value will be 1 only, right? Because the subarray with 2 is not present, right? After that we will move to the last index, that is 1. Okay, we will add here, we will get 3. Now again it will check this formula if it's present in the subarray or not, sorry, hash map or not. That is 3 minus 2, we got 1, right? We got 1. That means 1 2 and 3. That means after this point we have a subarray with some k, right? We are checking this only, that is sum minus k is equal to 1, right? This is k, this is 1, this whole thing is sum. 3 minus 2 is 1. A simple mathematical condition, right? So we got this as true. Then again we will increment the count, right? Count will be 2 now. Count will be 2. Again in the map we will put sum 3. Again it will check if 3 is already present in map or not. It's not present, so it will take 1, right? So that's it, we got the count as 2, right? Okay, so let's move to the next question. So the continuous subarray sum, given an array nums and an integer k, return true if number has a good subarray or false otherwise. A good subarray is a subarray where its length is at least 2 and the sum of the element of the subarray is a multiple of k. Okay, so two things are there. One is length as at least 2. It should be greater than 2 or equal to, right, at least 2. The second thing is sum of the elements of the subarray is a multiple of k, as a multiple of k, right? Sum as multiple of k, right? So in the question where we need to find the sum, we will use prefix sum. See, we need to check two things. One is if subarray we need to find, and within that if you need to find the sum, anything related to the sum, we will use prefix pattern. Okay, so two things are there. Length should be at least 2 and the sum is a multiple of k. Let's see the example. Subarray, what we just need to return true, okay, or false. This is the example given. Okay, so 23, 2, 4, 6, 7. This is the array given and the k is 6. So we need to find subarray length should be at least 2 or more than 2 and the sum is a multiple of 6. Okay, now how can we find it's a multiple of 6? Let's say we have a sum 10. How can we find? Using modulus. Okay, we can do modulus. We can check the remainder. If it's 0, it is a multiple of 6. If it's not 0, it's not, right? But here the brute force approach can be simple, right? We can find all subarrays using nested loops and then check if the sum, let's say x sum for x subarray is the modulus with 6 is 0. That means this is the correct subarray. We can return true, right? But that will take n square time complexity, right? This is the simple part, correct? But here we will be using prefix sum. How? This is important now. See, in the last question what we are doing, we were we were checking this formula, right? We were checking this formula. If this is present in the hash map, that means our subarray with some k is possible, right? But here what we need to do, what is the condition? The condition is we need to check if it's a multiple of 6 or not, right? The sum should be multiple of 6 or not. How can we do this now? See, in the question, can we store the remainder in the hash map? Let's say we got the sum as 10, right? 10% 6 is what? Modulus 6 is what? It's 4. Remainder is 4, right? So let's say we have a 2, 4. Let's say we have an array like this. Okay, so we got remainder as 4 here. After that we will move to the next element, right? Now sum is 12. Again we will check the modulus. It's what? It's 0, right? So this is one of the subarray, right? We can say it's one of the subarray. How we will use the map here, I will show you. Okay, the next we will go to the next element, that is 12 plus 4. It's what? It's 16, right? We will do modulus with 6. It's what? 4, right? Now in the question you can see what are the number of subarrays. This is the one subarray, right? 4 plus 6, its sum is 6, correct? It is the multiple of 6. And one is this one, 12. So there are basically two subarrays, right? So we can use map here or not? we can use. How? We will use remainder as the key 4, right, and the index, it will be 0. Here it will be 0 comma 1, here it will be 4 comma 2. So we will check when we will come to here, we will check if 4 is already present or not. It's already present, right, at index 0. So 10 2 4, right. At this point we got the remainder as 4, right, correct. And at this point again we got the remainder as 4. How this can be possible? 10 plus 6, see, 10 divided by 6 and 16 divided by 6, it's 4, right. So one thing we know, we get to know, like something between this is multiple of 6, right. That's why we got the same remainder, correct. From 10 to 16 something is there which is multiple of 6, for that we are getting the remainder as 0, and for that element, that is 10, we are again getting the remainder as 4. You got it? Okay, so let's code then. So in the last question, what we are doing, we are using the map. In the map the key was what? The key was the sum of subarray, right, the sum of subarrays, and the value was the number of subarrays with key sum, right, with key sum, right. For 0 let's say 2, right, and we are checking the formula sum minus k. So basically we are checking if the subarray with k sum is possible or not, and we are checking if this value is present in the hash map, that means it's present, right. So that's what we were doing in the last question, and in this question we are basically storing what? The remainder and the index. Okay, if we get the same remainder afterwards, that means there is something between the first occurrence and the second occurrence, and we can say true. Okay, so let's code this. So let's make the teacher, let's say remainder index new hash map. Okay, now we will be having one sum, and let's put the initial thing in this remainder sub hash map, that is for remainder 0 the index will be -1. Okay, after that let's start the for loop. Int I equal to 0, I less than nums dot length and I plus plus. Okay, within this first thing is we will be maintaining our prefix sum. So sum plus equal to nums of I, right. After that we will be calculating the remainder, right. Int remainder equal to sum modulus k, right. We will get the remainder, that is like 10 divided by 6, we will get 4. Now we will check if this is present in the hash map or not. Hash map dot contains key remainder. Then what we are doing, we will check if this is between the bound or not, right. So this is a valid we can say subarray or not. So I minus what? Remainder. Let's copy this only. If it's greater than 1, that means this is a valid subarray and we can return true, right? Otherwise, if it's not present, then we can put it, right? So remainder dot put what? Remainder. Okay. At the last we can return false. Let's run this. What is the issue? Remainder. Index also we need to put, that is I. It's accepted now. Okay, so I hope it's clear. Do you want me to dry run? Okay, let's dry run this. What was the given array? 23, 2, 4, 6, 7, anything will be there, right? And k was 6. So we need to find a subarray with length greater than equal to 2. So what we are checking here, right? So two conditions were there. One we are checking here, that is the length should be greater than equal to 2. We are checking here that thing. And what is the next thing? Multiple of 6, right? So it can be 12, it can be 18, it can be 6, anything will be there. So hash map, we will maintain the map. Within map we will be having remainder as the key, right? And the index. So let's start. When we start with the 23, 2, 4, 6, 7. So we start with the 23. Sum is 23 now. What is the remainder? That is 23 modulus 6. We will get what? It's 5, I think. Yes, 5. Okay. So we will put 5 and key index as 0. Right? Again, we will go to this 2. So it will be 25. What is the remainder now? It's 1, right? So we will put 1 and 0. Now it will go to 4. Plus 4, it's 29. What is the remainder? It's 5, right? So 5. Now it will check if this is present in the hash map or not. If it's present, that means there is something in between, right? Which is a multiple of 6, correct? So we got the remainder as 5 here, and we again got the remainder as 5 here. So there is in between after this until this point, which is a multiple of 6. So we got the array. Now we got the array subarray, which is a multiple of 6. Now we need to check the first point. So we are checking the condition. We are doing what? We are basically subtracting the index, that is I minus the index we stored for this, right? After this point only we got the subarray, which is multiple of 6. So we do I minus 0. What is the index? It's what is the current index? 0, 1, 2, right? 2 minus 0. We got 2, which is the greater than 1. So both the conditions is satisfied, this one also and this one also. So we return true. Got it, everyone? Okay. So the last question was also same. In that also we were using, like, here we were checking the remainder, because our condition was to check if it's a multiple of 6 or not, right? In the last question, what was the scenario? Map. We need to check the sum of the subarray, right? So we will store sum of subarray as key and their occurrences and number of subarrays as the value, right? And we were checking sum minus k, right? That means, let's say 1, 2, 3, 4. If we got sum here as 1, right? And again we are getting sum as, let's say we need to find the subarray with sum 2, right? This is the subarray 1, 1, 1, 1. This is the array given. So this is the subarray with sum 2. So here we will be checking this formula, that is sum minus k, right? That means 3 minus 2 is 1, if 1 is present or not. So that's what we are checking, the if the subarray with some 2 is present or not in the last question. So try to understand this, try it by yourself once.